Now I will be covering very brief idea about the polynomials. This topic find answer in class 9 and class 10, and I have found that most of the students studying in these classes often get confused with the very idea, which leads to the classification of any algebraic expression as polynomials, which ultimately leads to monomial, binomial sort of expressions. And to start with, I will begin with algebraic expression. What exactly is an algebraic expressions? We must have come across in our primary classes and heard terms like constants and variables. So constant are those numbers whose value remains unchanged, and these are all real numbers. And the other one is variable. Variable by its very dictionary meaning means something that varies, that keeps on changing. So such variable are usually expressed by small alphabets such as X, Y, Z, A, B and C in mathematics. So by making use of these constants and variables, by multiplying them, adding them, multiplying and adding together, whatever the expression that we get, such expression is known as algebraic expression. For example, I take 2 as a constant, x as a variable, and multiply these two terms. This becomes an algebraic expression. Where 2 is a coefficient of x, at the same time x is a coefficient of 2. Now take another example, say 3x plus 2. Here 2 is a constant, again 3 is a constant, but here 3 is a constant of x, or 3 is a coefficient of x. Again, this expression, which is made out of combination of variable and constants, this expression will be termed as algebraic expression, right? And how these algebraic expression changes to polynomials. So when we talk about polynomials, what are we exactly looking at is the powers of variables. Means in this expression 3x plus 2, you know x is the only variable present here. So for this expression to become a polynomial, we must look at this variable x, then we must look at its power. And here the power of x is 1 or plus 1. So what exactly would be a polynomial will depend on one major aspect, and that major aspect is the nature of the variable. Variable for any polynomial needs to be compulsorily a positive integer. When I say positive, it means I am talking about all those whole numbers whose values are more than or equal to 1. So these positive integers will be plus 1, plus 2, plus 3, plus 4, plus 5. It will never have any power this is all about power of the variable. The power of the variable must have positive integer. So these power should always be positive integer. They will never have values such as 0.23 or in any decimal number. It can never have values like -2, -3, -4. 2, it will also never have any value which is purely a rational number. Means expressions such as 1/2, 2/3, 5/6 or any number that comes to your mind, and if it forms the power of this x, then in that case as well the expression will never be called as polynomial. So with this I will give you a few examples and make this idea very clear to you. Expression number 1, y plus 2. First identify the variable. Here the variable is y, and what is its power? Power of this variable y is plus 1. See, y raised to power 1 is also written as plus 1. Now what have we seen here? Power of variable is, this is plus 1, which is nothing but a positive integer, right? So when we have power of variable in an algebraic expression to be a positive integer, we have no other variable here, then this expression will be a polynomial, right? Take another example, say 3x raised to power 2 plus 1. Again, here x is a variable, and what is the power of this variable? Power of x is again, here in this case it is plus 2. I am insisting on this plus sign just to make you clear that this positivity of the power has great significance in polynomial. It is only because of this positive nature of the power that any algebraic expression is classified as a polynomial. So again here we have no other variable other than x, and this variable x has a power of plus 2. So this expression is again termed as a polynomial. Let us make it a slightly complicated. X raised to power 1/2 plus 2. Now what is the variable here? Any idea? Right, variable is x here, and what is the power of x? Power of variable x is plus 1/2. Now look at this number, plus 1/2. Is this a positive integer? One thing, it has a positive sign, true, but what about this number 1/2? Is this an integer? No, this is not an integer. This is a rational number which will give rise to a decimal expression, and any power of this variable must not have any decimal format. And since it is not an integer, it is a decimal expression or decimal expansion of this 1/2, which is nothing but 0.5. So this expression, this algebraic expression will not be termed as a polynomial, or to put it simply, this is not a polynomial. So the only aberration that this variable got a power of 1/2 disqualified it from becoming a polynomial, right? Now let us bring home this concept by understanding more problems. Say I am writing 5 divided by x. plus 7. Now what is the variable here? Here the variable is no doubt x. But what about the power of x? Some of you would hurriedly deduce that the power of x is 1. But whether is it so? Okay. To scrutinize it, let us rewrite this expression in this form. 5 multiplied by 1 by x is nothing but the same expression. Now what is 1 by x? This 1 by x can always be written as x raised to power minus 1, and this plus 7 will remain unchanged. So this is 5x raised to power minus 1. Now what is the power of x now in this algebraic expression? The power of x raised to power minus 1 is minus 1. So power of x is minus 1, not plus 1, as you have seen in the very first step of this algebraic expression. So a care has to be taken while we are classifying any algebraic expression into a polynomial, and that care is you have to write this variable as a coefficient of a constant in such a way that this variable is expressed in the power of certain digits, and it will depend upon how this expression has been written. If it is written in this form of 1 by x, then this x will have a power of minus 1. But when the same constants and variables are so arranged which leads to this expression, then you will find that this variable x has a power which is plus 1. So there is no doubt about this thing. This algebraic expression becomes a polynomial, whereas the expressions written above is not a polynomial. And why it is not a polynomial? Simply because the power of the variable is a negative integer. For this expression to become a polynomial, it must have the power as positive integer only, which is not satisfied in this present case. So this property of x raised to power minus 1 again disqualifies this expression from becoming a polynomial. You will also find examples where you have expressions such as cube root of x multiplied by 6, say 2. Again, analyze this expression, this algebraic expression, and identify whether this is a polynomial or not. This algebraic expression can be written as x raised to power 1 by 3 plus 2. So here what did we get? Variable is x and the power of x is 1 by 3. It is positive 1 by 3. But again here this positive 1 by 3 is again not an integer, and since it is not an integer, this expression doesn't qualify to become a polynomial, so it is not a polynomial. Right, these were expressions where we have used only 2 terms, and when we increase the number of terms, how does the picture changes? Right, say now I have 5x to power 2 plus 2 multiplied by x plus 5. What about this expression? This is an algebraic expression, but whether this algebraic expression a polynomial or not. So the very first step that we need to adhere or stick to is first identify the variables. Here we have x, we have another x variable. The variables are x square and x. First analyze x square. What is the power of x square? So what is the power of this variable x here? The power of x in x square is plus 2. So this is a positive integer. So we have no problem with this first term. What about the second one? In x raised to power 1 or x, the power of x is plus 1. So again this variable has a positive integer as its power and there are no other variables. So both these variables satisfy the condition of positive integer value for its variable. So this becomes a polynomial, right? And let us complicate it further. Say suppose I write it like this. Now whether this is a polynomial or not, again we will go back to our basics where we will identify the variables, and here variables are 1x, another x, right? 1x is nx and another one is existing in x raised to power 2. Now first look at x cos square root of x. This can be written as x raised to power 1 by 2. And what is the power x raised to power 1 by 2? This is plus 1 by 2, right? Here it has a positive sign, no doubt, but what about this number 1 by 2? This 1 by 2 is not a integer, and when any variable in an algebraic expression is not an integer, it hardly makes any difference whether other variables are integer, whether other variables have their power as positive integer or not. Violation of this property by any variable in an algebraic expression will entirely rule out the possibility of this algebraic expression from its qualification as a polynomial. So this slight aberration in the power of x makes it an algebraic expression which is not a polynomial. So this algebraic expression is again not a polynomial, right? I hope this must have made your concept of polynomial somewhat better than what you must have learned so far from your own experiences. Now in this polynomial you have often come across words such as binomial, monomial, trinomial, right? So any algebraic expression which qualifies to be a polynomial, one, and which has only one term in it, such expression will be known as monomials. Mono means one, mial expressions, so it will be a monomial. When it has say two terms, 1 and 2, then and if this expression again qualifies to be a polynomial, and in this case it indeed is a polynomial because the variable x has a power of plus 1 which is a positive integer. So 3x plus 5 is a polynomial, but this polynomial has two terms, first term and this one the second term where it is a constant. So this becomes a binomial, means it is a polynomial algebraic expression which has two terms. Into bi means 2, and when it has 3 terms, say 5x plus 2, see the power of variable x, it is plus 2, positive integer, power of x is plus 1, again positive integer, this expression becomes a polynomial, right? And this polynomial has got 3 terms, 1, this is 2, and this is third term. So this becomes a trinomial. So this is how we classify any polynomial, any algebraic expression which is a polynomial into its monomial, binomial, trinomial groups. So I hope it will help you greatly in understanding the following chapters of polynomial, and must have cleared your doubts that you must have kept hidden, kept latent out of some fear or some other reasons. And thank you for watching this short video.